Okay, we're going to work with the quadratic formula. Most people are pretty familiar with the quadratic formula. And we did this in its entirety in Algebra 1, so it's more a review. Couple things to remember. When doing quadratic formula, using quadratic formula, the equation must equal 0. So make sure the equation is equal to 0 before you start identifying your A, B, and C. Okay? The second step is find the discriminant. And this is exactly how we did in Algebra 1. The discriminant is b squared minus 4a times c. You find the discriminant, and then you'll see I have a table under number 2 on your notes, because you have to be able to tell me what type of roots we're dealing with. So, if the discriminant is positive and a perfect square, I'm going to take this out. Then the type of root you have is 2 real rational roots. Rational meaning they can be written as fractions or whole numbers. Okay? If the discriminant is positive and not a perfect square, then you're going to have 2 real, they're still real roots, but they're going to be irrational, because you're going to be square rooting something that doesn't come out nicely. Okay? If the discriminant is 0, you have 1 real rational root. Remember, that's when the vertex is sitting on the x-axis. And then our last choice, this is the only difference from Algebra 1. In Algebra 1, if our discriminant came out to be negative, we could stop here and say no real roots. But you're older and wiser, and you now know about imaginary numbers. So now you have to continue it and find the 2 complex roots, or imaginary roots. So you can't just stop and say no real roots. All right? So once you define the type of root you're dealing with, the next thing you want to do is finish the quadratic formula. You don't have to memorize it. Now, if you have to take your SAT at whatever point, some of you may or may not have to take it, you do need to memorize it for the SAT. They do not have it on there. X equals negative b plus or minus the square root of the discriminant, which we already have figured out, b squared minus 4ac. All over this whole thing, you got to get the answer on the top first, over 2a. 4th step, simplify. And the 5th step is solve the formula, and sometimes you have to solve it twice, depending on the type of root. So up here in step 2, you'll know if you need to solve it twice. Okay? All right, let's do a couple just as practice. All right. Examples. Number 1 is 4x squared plus 8x plus 7 equals 4. First thing, it's not equal to 0. So before you identify anything, you need to subtract that 4 from both sides, or you're going to get it wrong. You get 4x squared plus 8x plus 3 equals 0. Now, I didn't put this in the steps, but I always identify my A, B, and C. Fine, do the discriminant first. Remember, the discriminant is b squared minus 4ac. So b is 8 squared, and this is where you got to watch your negatives. This one's all positive, so that makes it easier. 4 times 3. I finish this out, use my calculator, and I find it's 16. 16 is the perfect square, and it's positive. So if it's a positive perfect square, we know the type of roots we're going to have is two real rational roots. So that's our first question. I'm going to ask you, what's the discriminant? Then I'm going to ask you the type of roots, and then I'm going to ask you, what's the solution? Okay, so this is where we finish out negative b plus or minus the square root of the discriminant all over 2a. Okay, so let's go from there. And this is x equals, or because we're finding the solution. Negative b is going to be negative 8 plus or minus, we already know is 16 is the discriminant, all over 2, and a was 4. Now this is where I say to simplify first. So I'm going to simplify it as I can. And this is going to be negative 8 plus or minus 4 all over 8. And then I'm going to split it. I have negative 8 plus 4 over 8. And I have negative 8 minus 4 over 8. And then I get my two answers that way. Okay? And my two answers are negative 1/2 and negative 3/2. Okay? And they need to be simplified all the way down. Okay, this should look really familiar to you guys. Most people really like quadratic formula. Well, like when you compare it to other ways of doing things. I know most of you probably don't sit around and do just quadratic formula for fun. I never said that I do, but maybe some of us do. All right, next one. There's actually two ways you could do this, but if I'm asking you to use quadratic formula, the first thing you got to do is set it equal to 0. And this is the type you got to be careful of. If you're missing something, you have a 0 in there. Well, a is 5 because that's what's, a is connected to the x squared. B is always connected to the plain old x, so we don't have a plain old x here, so it's 0. And c is the constant, so it doesn't have an x attached to it. So let's do our discriminant, which is b squared minus 4ac. So b squared is 0 squared minus 4 times 5 times negative 80. And so that comes out to 1600. Well, guess what? That's two real rational roots because that's a perfect square. If you're not sure if it's a perfect square, put it in your calculator, do square root of 1600. If you get a whole number, then you know you got a perfect square. Now let's finish up our quadratic formula. So that's going to be negative b, x is equal to negative b, well that's negative 0, plus or minus the square root of 1600 all over 2a. Let's simplify. That's really going to be x equals plus or minus 40 over 10. Let's split it. 40 over 10 and negative 40 over 10. So our answer is going to be 4 and negative 4. Okay, some of you can stop at this point. I'm going to do two more examples for those of you who want a couple more examples. Number 3 is 7x squared plus 6x plus 2. It's already equal to 0, so we can just start identifying A, B, and C. Let's do the discriminant. B squared minus 2AC. And that's going to be negative 20. Now I go back to my table and I see if my discriminant is negative, I'm going to have two complex roots. I'm going to have imaginary answers here. Okay? Let's finish out our quadratic formula. X is equal to negative b plus or minus the square root of the discriminant all over 2a. And this is where if you did not learn imaginary numbers, you're going to be in trouble. If you leave the negative under there, that's not right. It's going to be x equals negative 6 plus or minus 2i root 5. Now let me show you where I got that. The square root of negative 20 is really square root of negative 1 times 2 times 2 times 5. Well, in this case, the 2's can come out, and the square root of negative 1 is I. Remember, something horrible happens, and 5 is left behind. So that's where I got this. And that's all over 14. Now this is where you got to be careful. There's no more simplifying here, so we split it up. And we have negative 6 plus 2i root 5 over 14 and negative 6 minus 2i root 5 over 14. Now here's where it gets tricky. If all the outside numbers are divisible by 2, we can actually simplify out a 2 here. So really what we have here is negative 3 plus I root 5 over 7. I did the 6, the 2, and the 14 by 2. And negative 3 minus I root 5 over 7. I will tell you, if you give me this as an answer, I will give you full credit. So if you forget to simplify it, because that is very complicated, then I will give you that. If you don't give me I as an answer, if you try to give me a decimal answer, I'm going to take points away. Well, first of all, if you tried to put this in your calculator, you're going to get an error, because your calculator is not going to do a square root of a negative. It's going to tell you it's not in the right mode. All right, so some of you need to go back, and some of you never did I. You just skipped that part. So x squared, last one, plus, whoops, sorry, minus 8x minus 17 equals 0. Already equal to 0. A is 1. B is negative 8. C is negative 17. I'm not going to actually do this one all the way out. It's going to be your discriminant is 132. So that's 2 irrational roots. And the answer here is going to be x equals 4 plus root 33 and 4 minus root 33. Okay, see if you can get those answers. I will do that one in class if you need me to.